check, check. Check, check. Sounds good. Green light. Come on, come on, come on. Wait, green light. So, I gotta turn this off. I don't want those coming up. So, we're doing section 3.2 today, logarithmic functions. If we'll go as far as we can. I know today's kind of a weird day. It's still a regular full class, but we'll do what we can. Change logarithms from exponential form to, from logarithm to exponential, exponential to logarithm. There's just places where the numbers need to go. We'll do some evaluation of some logarithms. I'll tell you exactly what they are, and then we'll do some basic logarithm properties, graph some logarithmic functions if we can, talk about domain range, use common logarithms, and then natural logarithms. Natural logarithms. Cool? Any questions on any one of those? I know if you don't know what they are yet, that's okay, we're going to get to them. If you have questions at any point, please make sure that you ask them or forever be confused. All right, let's get started with our log base. It's going to be right here. Here is how you switch between a logarithm and an exponential function. Let me just go ahead and do that on a different slide. When we're working with powers, we have some base value to an exponent. Okay? And that equals some answer, correct? So I'll use my notation. We have a base number, there's an exponent, and then there's an answer. Can someone tell me what the power here is? We talked about this. It's the whole thing. E is the exponent. E is not the power. This is b to the e power. Make sure that you keep that together. So if I have something like this is x to the third power. If I say, hey, what's power here? You say x to the third. You don't say 3 because 3 is the exponent. Okay, please remember that. Don't come puzzle this. All right. Now we can go between in both directions, between our exponent form and our logarithm form. Before I show you that, let me tell you what a logarithm is. Does anybody know what a logarithm really is? Sure. Well, no? So let's talk about that real quick. So if I ask for a quotient, what am I looking for? The answer to a division problem, right? If I ask for a difference, then that's the answer to a subtraction problem. When I'm asking for a logarithm, all I'm asking for really is an exponent. So let me show you something here. If I had 2 to some value and I got 8, you've seen those problems, correct? Well, this is a poorly written problem. It's not really poorly written, but that's not the way we would ask mathematically. Okay? Now everybody knows what x is, yeah? What is x? 3. X is just 3. But the way we should ask it is going to be, hey, log base 2, 8. And now I say, hey, okay, look, I had some exponent. This is a call for an exponent. My base value was 2, so 2 to some number gave me an 8. What is that value? And then that you would spit out 3. That's all it really is, okay? So when you see logarithms, they're asking for what are they asking for? Exponent. What are they asking for? Exponent. An exponent. So let's go back to here. So to switch between the two, we're going to do log base. This time his answer is going to be the exponent. Okay, so all this really is a call for an exponent. And that's how you switch between the two. Whatever base value was here would go down below on the base for the log. The answer would go right in front of that. And you're looking for an exponent, therefore that's what the solution would be. Questions on this? Oh, I got some hazelnut in my coffee today. Any coffee connoisseurs in here?
Yes.
Yeah. Any water connoisseurs?
Yes.
Man,
Fiji be too rich for me.
Fiji's bomb though.
Yeah, that'd be the water of choice, but
Fiji,
I can't afford $5.
Fiji's delicious. I like Voss better. It's like,
Could not be $5.
I used to be a Dasani fan until I had Aquafina. Now I'm Aquafina all the way, bro. Like if we're gonna buy just water, and you know what else is good too? That Costco water.
Yeah, the grocery store waters go hard, but yeah, fries is my number one grocery store, but
You know which one's the one I don't like the most? But it's supposed to be the best one? Arrowhead.
Arrowhead is food. Arrowhead is food.
Yeah, but it's the most, it's,
It's just
no.
like minerals.
Everything else that we drink is toilet water. They really do just take water from the hose and they filter it. Here's what they've done. They've taken out all of the nutrients and minerals and everything, and it's just, it really is just H2. What? I guess so. Alright, so 1, 2, 3, all eyes on me. That's too long. I like waterfalls still. Waterfalls! That's better. That's faster. Here we go. So let's take a look at these. If you want to change these around, this log, if we're going to go from this logarithmic form to exponential form, then what would this top one become?
X to 7.
It would be 7 to the
X
to the third is equal to x. That's a better question, isn't it? In this case? How about this next one? B to the second is equal to 25. How about the last one?
4 to the y. 4 to the y
Yeah. 4 to the
Yeah.
y equals 26.
That would be 4 to the y is equal to 26. Cool. All right, question. Sorry. I did do that kind of fast.
It's not going to.
I'm finna get this.
I'm going to get all kinds of hits tonight on my.
Oh, we already did.
Hey, I'm here for you. I will always be here for you.
I will remember. Is this weird, or do you guys like see how cold you can stay in the shower?
I do that.
Yeah. Have you ever done that when you were like a kid or an adult? Like you turn it as cold as you can, see how long you can stand in there. It wakes you the hell up. Hot? Okay. I ain't no damn lobster.
Sounds like we're done here, so let's move on. I've got 3 to the second is equal to 9. What am I asking you for? What's the answer to this? 2.
It's 3.
It is 3 to
The exponent.
Oh, yeah, the exponent.
3.
It's asking for the exponent.
Oh my god. We're not gonna-
I just woke up and it's cold today, So you just made a point for me. People that have issues with logarithms don't really have issues with the logarithm themselves because all that really is asking for is an exponent. But people tend to want to multiply
Yeah.
in their minds, and that's when they get it wrong.
3 times 3.
You really need to be careful with that because those are going to be the mistakes you see. And I have to tell you right now that if when you come back to go over your test and those are the mistakes you're making, I cannot give you the points. Understood?
Sir.
Okay. That's all I'm saying. Just throwing that out there. All right, here, go ahead and convert those into logarithms then. Take those 3, convert them into logarithms for me. Give you guys a butt on my mute. I don't wanna.
He's hydrated, Zach. He's hydrated.
You already got one.
Before it.
Gotta make sure I take my umbrella. What? Sure.
Do it. Do it. Hey, give us a twirl. Give us a twirl.
Yeah.
truck is all black. So what I carry in my truck is an umbrella slash cane. It has the wooden tip and the handle, and I can just slap something. Oh! I was so mad that I forgot this when we had our that pep assembly out there. Like I always take it, and man, I want to just come back like I just want to get my umbrella. Okay, here's what you should get. Log base 2 x equals 5. Beautiful. Now, is this going to be an integer?
No. Yep. No. No.
Yeah.
Wait. Yep.
How about the next one? What am I doing here? Log base b 27 equals 3. Last one. Log base e. Okay. Sounds good. Cool beans. What is this?
Wait. 2.
No, it's just 2.
Oh yeah. Did you do that? I'll tell you, that's where people make the most mistakes. Like you know what you have to do, but in your mind is like, and I do it too, so don't even feel bad. And I've been doing this for a long time. This should be how much? 2. How much is this right here? Huh? Oh. -3, right?
Yeah.
-3. Nice. How about this right here? 6?
Pause. You reverse that one.
Isn't that -2?
I'll put my name down, flip it, and reverse it.
I need you to flip it outside things real quick. So -3.
-3. Now this is why. So let me show you why, okay? Oh, where's my marker? Where's my marker? So let's go exponential real quick, okay? What's my base number? 5. What's my exponent? I don't know. We're going to look for that, right? And the answer should be 1 over 125. Now, to make this guy a fraction, I'm going to have to flip it, aren't I? So I have to make it a negative number. And then 5 times 5 times 5 would give me my 125.
There you go.
You see that?
Yeah, I see it.
Cool. All right, cool beans. Right here, huh? What that going to be? Right there, man.
That's -2, sir.
Oh wait, no. It's gonna be like 2 over 3.
I believe it's -2.
Sharice, what'd you get?
Oh, for that, I'm gonna do it right now.
No, you do it, not your calculator.
It's like 2.
And,
The calculator is an extension.
It's my electronic best friend.
I'm trying to call it -2.
Got it. 1/2.
That's what I think. -1/2.
1/2.
0.5. Oh.
Oh, it's 1/2. Kill him, Forbes. Kill him.
1/2. Good job. This is why.
Who's this?
Let's go and take this quick. We have a 36. We want to get a 6. That means we want to make this smaller number. That means we can't take it to some exponent, which is going to be a prompt for some type of fraction, because then you're doing the power divided by the root of that number. So 36 with the first power is just 36, and the square root of 36 will give you your 6. No, that's him right there.
Kill him, Forbes.
Kill it, yo. Okay. How about that right there? Oh. Oh.
Damn.
I like
Oh,
that.
damn. What kind of party don't you understand?
It's exactly like the last problem,
That's cap.
except this one doesn't have a root, so it stays that way. Okay.
I'll take it.
So I was waiting for blue.
What?
You have a question on this one?
Oh, no.
Because I heard you mumbling. I was like,
Oh, I was talking about.
Heard him out.
good. Darn, I was working with whole numbers. Gotta throw in some radicals. What's my base number here? 3 to some number, right? Now, let me show you the easiest way to do this one. You ready? Okay. This is 3 to some exponent. That's going to give me the 7th root of 3, correct? all I'm going to ask you to do is turn it into a power. Remember, it's power over the root, correct?
Yeah.
First power, seventh root. So if I have this, and this is actually one of our properties that we're going to learn. If the bases are the same, then shouldn't the exponents be the same? We're saying this is equal to that, right? So if the bases are the same, then the exponent should be the same. That means that x is 1/7.
That's a lot of damage.
What?
That's a lot of damage. All right.
Wait,
I don't know that one.
From flex statement.
Questions on this? It's the power over the root. So what's the power on 3? 1, right? And the root is 7. So it's power over root. Can I change the slide? Can I change the slide, snippy slide? C. Okay. So here's some of the rules we're talking about. Log base b of b. You see that? Has to be 1. Because the only way to have a base number spit out the same answer is if the exponent was a 1. So log base b of b is equal to 1. Does that make sense?
Yeah.
No? Let me show you.
Okay,
If. So here's what I'm saying. If I had log 5 of 5,
That's 1.
exactly, that's what we're saying.
Oh, sick. Okay.
That's all we're saying. Because the only way to get 5 to some exponent and get 5 back out is if that exponent is 1. Because anything to the first power is itself, correct?
Yeah.
On the same note, log base b 1, log base b of 1 has to be 0. Because if you take anything to the 0 power, what should you get? 1, and that's why there's a 1 in the answer spot. So anything to the 0 power gives you 1. Right?
Sounds about right.
Make sure you understand it. Don't just like joke about it and try to move on. Because he's going to come, okay.
We'll find out.
I love that you're making light of it, but
Anything to the 0's power is 1. So anything.
so log base b1 it should always be 0. Please make sure you understand these properties. They're pretty simple ideas, and they become very, very useful. What am I doing with language lately? Yesterday I kept saying sophomore. Sophomore. We were doing a statistic probability problem about juniors, seniors, and sophomores that drive to school, and I kept saying sophomores. Oh, the sophomores. What's the count of sophomores? How many of those sophomores drive? That's how you spell it. The O is silent.
Yeah, it makes sense, but you don't say block.
Yeah, see, this is why I hate the English language. The entire alphabet can be silent. Like when you say almond.
Almond?
No, it's not almond. It's almond. The L is silent. Or salmon. The L is silent. Right? I used to say salmon. Hey, let's get some of that salmon. Nope, that's salmon. Oh, okay. It's like the whole thing could be. The entire alphabet is a joke, man. Alright, I'm gonna move on before I go off on my English tangent. Alright, so check this out. What's log base 99? 1. Beautiful. What's log base BB? Oh, wait a minute. I already had it. Okay, I forgot to take the answers off. I'm going to, let me go back real quick.
We can see the answers now.
I know, that's what I'm saying. Let me delete these real quick.
Yeah, everybody close your eyes.
Delete it.
No. Well, I'm not going to delete them. I'm going to erase them. I'm going to check on my eraser. You guys ready?
Yeah.
She's gonna color him.
Whoa.
Oh.
Alright, class. Evaluate log base.
Let me save this.
Wait.
I have to save it. Okay. Did I do the same thing here? No. Oh, more properties. More properties. You want these. Log base b of b to the x is going to be equal to x. Log base b of b to the x is going to be equal to x. If you think about this, aren't exponents and logarithms opposites of each other? They're inverse operations,
Wait, hold
correct?
on. You gotta let me write this. You're spitting too many facts. My brain can't keep up. I know. I understand, but whoa.
He said to slow him down.
Oh, I don't want to get rid of the properties part.
Wait, can you show that in like a problem?
So,
Okay, 5x.
think about this. Log base is going to be a call for an exponent, right? And that's supposed to be the opposite of a power. So if you have a power and the opposite of a power, they just kind of bleh. Same idea. See, this is a power, and then I have a logarithm, which are inverse operations. So a power to a logarithm, inverse operations, blah. Make sense? So they're the same idea. Every operation has its inverse. The opposite of powers, logarithms. What does the second one mean? It's the same thing as this one, except in reverse. See, logarithms and exponents are opposites of each other in ideas, right? So if I have a logarithm and I have an exponent, do you see that power here? Then the power b is going to get rid of the log base b. They're going to be opposite. Boom, gone. And this is the reciprocal. It's a power of something, and that something is a log. So these two will cancel each other out, and you're going to get x is equal x.
It's Shirley Temple, America's favorite little child.
Little child.
I don't know what they say in the
You
commercial.
remember that commercial, though, right? Shirley Temple.
Animal crack course in my.
Oh my goodness, that's so old.
And she's
No,
like,
I don't remember.
she's like,
I never got to see it myself.
she's dancing in and out
Not
of the
that
black and white into color.
Yeah.
Half and half.
They have like
She's like, it's the 12 disc DVD set. Half of them are black and white, half of them are in color.
and then she's like singing too.
Yeah, she's like dancing and then she hits the boom over the color, and then you're on the cartoon.
I gotta go see that now.
Oh, man.
If you can't just see that being opposites of each other, break it down. If this was a logarithm, what would my base be? If I was going to go back to exponential form, my base would be b, correct? What would my exponent be on this? X. And what would the answer be? B to the x. So question, if I'm looking for x, what is the value of x? X. Same thing over here. Same thing over here. Over here. If I go to logarithms, I would have log base what? B. The answer would be x, and that would equal log bx. Do the bottom one again? So this one's an exponential form, and we're going to log, right? So I want to go log of the base, which is b. I'm going to put the answer up front, and that should equal my exponent, correct? And what's my exponent? Log base b
You know how
x.
she's got like the tightest ponytail in the world? She's suffocating her brain.
So these two are really equivalent kind of thing. Whenever you see them, they're going to just think about them as inverse operations that cancel each other out. Ready?
Yeah.
Check it out. What's that going to be? How much? 8. That was easy. How much is this?
17.
That was easy.
He's that one button. You just literally cross out everything else. And then
That's what I'm saying. They're kind of like inverse operations. Okay? We're not going to graph these right now. You can throw them in your calculator. You're going to see that they're going to be two graphs. That remember when we were doing inverse functions and how they would be symmetric about the line y equals x? Same idea. That's what you're going to see. Okay? All right.
Like this.
Let's move on. Oh, so we're talking about domains. I guess we should graph them then, so you guys can see them.
I write with my pinky.
whoa.
Oh, dog, I knew
Dog.
Wait,
What?
wait.
Oh my god.
Yeah.
Is he right?
Yeah, you write better than I do.
Oh yeah, no, this could be.
I write
fire,
garbage.
right?
You see my garbage. I do it all.
I feel like there's more control.
Yeah, this is how you write.
But I
in
have
cursive.
seen in high school the people that write with a fist, and it works. It's not very nice, but they do it.
Yeah, honestly, this is cursive right here. This is how you write in cursive.
You can't curse it, man. I've seen you. You just write a bunch of squiggles.
What you mean?
Yeah, I'd be like, Isaac, write your name in cursive. He'd be like,
I mean,
that says Isaac.
you're not wrong.
Isaac, write your last name in cursive. There it is. I'm just kidding. I'm planning on you, dude.
I mean, it really makes sense.
He said, really makes sense.
You should be writing in Times New Roman.
Comic Sans.
No, that's how I write real life shit.
Okay, clear this. Y. Let's clear this. Oh, that was awesome. That was so fun. So 3 to the x. 3 to the x. What's that going to look like, yo? You guys remember? Is that kind of exponential growth type thing that we did? Boom, there it is, right? Now our logarithm, yeah, 0, 1. So, okay. So if that's going to cross 0, 1, then what will the logarithm cross?
1, 0.
Yes, good job. Good job. Because remember what happens with inverse functions? All the x's and y's swap. So here, let's do that. So let's go y equals, and we're going to go, how do we write this in the log?
Oh, you go down. Well, go down.
Oh, hold on.
No, it's log.
Who's the guy?
Where'd it go?
It's log base 3x.
There we go. Thank you. So here's your log base button, guys. If you go into math, and I believe it's if you push up, you're going to see this log base. That's going to let you put in a base value. Oops, wrong spot. JK.
There it is. PTSD, now I'm having a flashback.
Okay, so math, push up, you're going to get log base. That's going to let you put everything in there. Okay, so we're doing 3, and then my variable is x. So let's graph those real quick. Here comes our 3 to the x, which is our exponential growth. And then we're going to get our logarithm, and it's going to cross the point.
Watch out, boy, she'll chew you up.
There it is.
Kill him.
Now, oh, I like that tongue too. Now, why doesn't this show me the rest of the asymptote? Because
Because we don't even see it.
that's just a limitation of the software. Because what the software is going to do is it's going to start to, it'll plot the points, but when it gets to that point, remember how there's really no change? It'll just start rounding to 0, and therefore it doesn't put it in there anymore. So that's why you only see that little dip of it. But you should know that it really does just continue and just scroll all the way down.
Of course we do.
I'm just saying because some people will draw that on their tests.
Oh, swear.
Swear to God. And then, yeah, and then you're wrong. And you fool, you're wrong. Swear to God. Swear to God. Swear to God.
That's a slant, right?
No.
No?
No. What,
Swear.
what would the stand asymptote be?
2 days ago. And we don't say it.
Here?
Like to the origin.
Oh, no. Let me square this off for you real quick. What we're really looking at is 2 functions that are symmetrical. So let me go with zoom first. I'm going to square it off. 5. Was it already in square mode?
Nobody.
Come on!
Nobody.
No. I don't want to do that. I don't want to stop it. There really isn't an asymptote, but there is going to be the line y equals x in there, which is what this function is, should be able to reflect across. Okay? So if I could take this thing and mirror it right over, it would pancake right on top of that.
Oh, yeah.
That's what that is. Not an asymptote. The only asymptotes here is one for this guy, which is this line. The asymptote for this guy is the y-axis. Okay? 2 different functions. Alrighty
Jay is so weird.
Okay, so let's go back and take a look at that real quick.
How did my signature get up, though?
It took me like 10 seconds. Domain of this function. Take a look at the red one. What's my domain here?
All round numbers.
No, it's not.
0
The zero bracket or zero parenthesis? Zero parenthesis to positive infinity. Domain on this guy?
negative or no, 0 to infinity.
This one's actually negative infinity to positive infinity.
Okay.
This one is positive infinity to negative infinity. Because remember, this thing is growing, right? It might be going really, really slow, but it's going to get to infinity at some point. And it's going that way to infinity. Now remember, those will, so let's do this real quick. So the domain on this guy, on the blue, let me use blue. So the domain on the blue one is going to go negative infinita to positive infinita, and then the range is going to go from 0 to positive infinita. What happens when we're looking at inverse functions?
The domain and range flip.
The domain and range flip. So this is the domain for that one. You see how that's true?
Yeah.
And then the range for this one becomes the other guy. Is that what you were saying, Mr. Munoz? Yeah. Cool. Sign. Go back to what? The calculator? Take like 30.
Oh, that one weird ass one for
Hey, watch your words.
language.
Weird ass.
Oh, my fault. That weirdo. What's her name?
You can say glass.
No, for Missy. For Missy, fam. You're bad girl.
Yeah.
What's your business?
Okie dokie, artichoke. I can change it now?
Lola is my old dude. Lola's a five.
Okay. We'll just go one by one on these. That way it's not too cray-cray. First one, the domain of f of x is log base b of x consists of all positive numbers from 0 to positive infinity. And we just said that, didn't we? Okay? And the range goes from negative infinita to positive infinita. The graph of the logarithm forms f of x log base x passed through the point 1 comma 0. Therefore, f of 1 is going to equal to 0. The x-intercept, is there x-intercepts? Are there x-intercepts on the blue line? There wasn't any, were there? It's asymptotic. There's only going to be a y-intercept. Just like this guy, it's not going to have a y-intercept. He's only going to have an x-intercept. Remember, everything gets reversed, doesn't it? If b is greater than 1, then the graph goes up and to the right and is an increasing function. If it's a fraction, it's going to be a decreasing function. And it does not touch the x-axis. Sorry, it does not touch the y-axis. It approaches it but doesn't touch it. Stuff we already said. I think we said this as well. Why do I have all the answers up here? I'm like sleeping on the job. Stop! Hammer time. Oh my god. I'm going to scream at this computer. I need my eraser.
You don't do anything.
Yes, I do.
I got some flash. Well, sorry.
I'm right here. Oh, look, this is a great example. You guys remember how we were talking about the exponential function and how a, h, and k affect the function?
Yeah.
A moves it up and down. Sorry, A is a vertical stretch or shrink. H is a side-to-side shift. K is an up and down shift. Take a look at this function without even talking about it. Correlate what you've known about a, h, and k to this guy right here.
Log 4 is A.
So what's going on with this log 4 function?
That's A. That's a vertical stretch or shrink, right?
No, it's going to the right 5.
It's going to the right 5 units.
I say.
That's an h function, yeah. So,
There's no way.
do you see an a up front?
Oh, so it's
Is it before the log or after the log?
It should be up front. Because remember, you're multiplying the entire thing by some factor that stretches it or shrinks it.
Okay.
So it should be up front.
Okay.
Okay? And then if there's a k value, it should be
Up or down?
up in the front. Not up front, I mean, all the way to the back.
Yeah.
I'm thinking of a line, but it's not in the front. It's going to be at the end of the function. So let's take a look at that real quick. Let's go back to him.
Not possibly, yeah. I would have died.
Do we need to see that, or are you guys okay with it? Anybody want to see it in a graph?
Good.
I think we're good.
Transposed.
We're almost done.
If you feel like
Hang in there, hang in there. Same thing.
Wait, that's the domain. Oh, that's the same thing.
It's the same idea. Because we're just going to shift it, that means that your function is going to go from 5 to positive infinity instead of being at 0. Okay? Let's see, the logarithm-based function. Yeah. So, something for you guys to know. When we're working with logs, our base system is a base 10, right? Because we have 10 fingers?
What?
Yeah. Our system is a base 10 because we have 10 fingers.
Pause. Explain. What is the origin story behind this?
So Munoz thought of this.
It's gonna be way too long. No, but it's really true. And you guys would know The Simpsons, right?
Yeah.
Hold on. You cannot possibly.
I'm gonna go there. And if you want to know about this, read the book.
The Simpsons is already shook.
So how many fingers do The Simpsons have?
9.
They only have
Another
8
8,
fingers.
yeah.
So all their math is in the base 8. Even pi is in the base 8.
What math
But-
do they do?
But why did it?
I know. I was go look for it. Here, I'll tell you once I get
What does
done.
that have to do with us?
Yeah, why?
Oh, because we're gonna talk about logarithms. Remember we said we're base 10. So logarithms. Remember it's logarithm base something, correct? And I'll tell you if it's a base. Thank you. So we're talking about logarithm, and it goes logarithm, log, and then there's a base number, correct? And we have to specify what base that is. So it could be a base, it could be a 2, 3, 4, whatever. Well, if I just give you this is a legit question. And that what is it?
2.
How do you know it's 2? What's my base? Exactly. So if you see log by itself, it's understood it's a base
Of 10.
10.
Well, why does that have to do with our fingers?
Yeah, there's most of our there's these stories that our math is a base 10 because we have 10 fingers. And that's how we count everything into tens.
But what if it's just because it's even and it's a clean?
No, there's a lot to it. You should research it. You're really that interested. And then I was like, okay, that kind of makes sense, right? Because then we can change the other bases. As actually, we've experimented with other bases before. Like when Egypt was, when we were, you know how Egyptians create some of the math? They actually used to use a base 60.
They have 60 fingers?
No, they didn't have 60 fingers. But it's just kind of a funny thing. Anyways, but they used to use a base 60 to try to figure everything out with 60s, because 60s were a really nice number because of the way that they weighted things. They used to use scales. Everything that they had was in some form of 60. We still have some remnants of base 60
Minutes.
in our clock system.
Whoa. Damn you.
Wait, what about like degrees?
And our degrees and stuff and all that. So when we're talking about, the whole, how many degrees? We have 360 degrees, which is a base 60 idea as well. So we have some of those things as well.
How would these extra fingers help you build it?
Dog, you can grab a whole block of
Not if you ain't got no guns, man.
just like this.
Let's move on.
They probably have like biceps on their
Okay,
fingers too.
here, make sure that you have these. I think we've already covered these. We've already covered these. Make sure that you guys write them down. Make sure that you have them.
Wait, what if they're all together?
Yeah, they're kind of nice together, aren't they?
Wait, no. Riley tell you that you like being on your phone.
I got you. I got it.
I gotta show you that. There's some guy from England wrote the book on the Simpsons math. It's really, really cool.
I wish I could get famous off of writing a book about the Simpsons.
Well, he was already famous before that.
Oh,
He's a mathematician.
that makes sense.
They appreciate their mathematicians anyway. They really do. We don't.
John F. Kennedy.
Hey, JFK. Dog. Hello?
You guys good with this one? You guys got your picks?
Hold on. Hey, Kennedy, what? Doug.
Watch your head real quick. Watch your head real quick. The whole time we were just like,
John F. Kennedy. Pardon me.
Mr. President.
Senor
There we go.
Roosevelt.
Hey, Nate.
We're good?
Si, senor.
Bro, when you drink something super hot, you can feel it through your whole like esophagus.
MJ. Oh, that was super. I only put a couple cubes in it too, because like I wanted it to stay fresh, because we're going outside. I didn't know we got that cold. I got a pain in my chest.
Did you say cubes?
Yeah, you said that right?
Okay. Like ice cube.
I
Okay.
heard something else.
Oh,
Okay.
Here's the other block. Oh no, that's the same one. No, it's not. No, it's not. Oh, I forgot something. I forgot something.
Some tweezers.
So smoke goes up.
So, what is this called? This is a log base 10, correct?
Base 10.
Do you guys remember we were talking about E yesterday? Okay. E is a number, isn't it? So we could have also something called a log base E,
Oh.
right? Eventually, does that make sense? Like, if E is a number, then I can do log base E. You might see that, but you should not. Instead of log base E, what we will have is something called ln. And I don't know why it's ln and not nl, because that's natural log, but it's ln. So ln is simply log base E. Okay? No, it's just natural log. They're not opposites.
Maybe it's log base natural.
I know, right?
No, I understand it's the opposite. because
Okay.
NL and then LN.
Log base. That makes more sense than I could ever think. I really didn't care. That's the way I was taught. So ln is natural log. Maybe because it comes from land or something. I don't know. Logarithms naturalis.
Let's call it lateral log instead.
Lateral? No. That's for the. That's for the imaginary.
I'm getting mad penguin vibes.
No, you're not.
Oh
I used to watch a lot of Batman, so I know what you're talking about.
no! Did you watch the TV show?
Dude, I watched
Oh
all
my
of it.
God.